Have you ever wondered what happens when you create a TensorFlow session? It can be a bit confusing, especially when you see those logs popping up. Today, we're diving into the details of what a TensorFlow session does and why it consumes so much GPU memory. I totally get it. Seeing your GPU memory usage spike to 90% can be alarming. You're not alone in this concern. Many users have experienced similar issues, and it's completely valid to question what's going on. Here's the specific situation we're addressing. A user recently asked why their TensorFlow session consumes so much GPU memory. They shared a log showing their GeForce GTX Titan Black and expressed confusion about whether TensorFlow takes control of the GPU. Sound familiar? Let's explore this together. So what exactly is happening when you create a TensorFlow session? Essentially, TensorFlow initializes the GPU and allocates memory for its operations. This is necessary for efficient computation, but it can lead to high memory usage, especially with large models. And stick around. At the end of this video, I'll share a tip on how to manage your GPU memory more effectively, which you won't want to miss. To understand what a TensorFlow session does, let's start by explaining its role in managing resources. When the user creates a session, TensorFlow initializes the computational graph and allocates resources, including GPU memory. Next, the user should know that TensorFlow takes control of the GPU to optimize performance. This means it will reserve a significant portion of the GPU memory for its operations, which is why the user sees high memory consumption. Additionally, the user might notice that TensorFlow pre-allocates memory on the GPU. This is done to improve performance by reducing the overhead of memory allocation during execution. If the user wants to manage GPU memory usage more effectively, they can configure TensorFlow to allow memory growth. This setting enables TensorFlow to allocate memory as needed, rather than reserving a large block up front. Finally, the user should monitor their GPU usage to ensure that TensorFlow is utilizing resources efficiently. Tools like NVIDIA's System Management Interface can help track memory usage and performance. Fun fact, the first GPUs were designed for rendering graphics, but now they power everything from deep learning to cryptocurrency mining. Talk about a glow-up. Now, let's look at the answers provided by other users. According to another user, TensorFlow sessions allocate nearly all GPU memory upon startup. This strategy allows them to bypass the CUDA allocator, which can help improve performance. Here's that tip I promised. Regularly check your TensorFlow configurations and monitor your GPU usage. This will help you optimize performance and avoid memory issues in the future. And there you have it. Understanding TensorFlow sessions and managing GPU memory can make a huge difference in your workflow. If you found this video helpful, please subscribe for more insights and remember to keep experimenting with your configurations.